the cable tester project, and we're just testing a circuit and describing the path that the current takes. Basically what I have with me for this project is the 9-volt battery. I have a tip sleeve cable, TS cable. I have some resistors, and I have a bunch of alligator clips. And I also have this nifty little LED, and this is, I need to power this with the 9-volt and all these other cables. So first thing I did was I had to figure out, well, I already knew that the max amount of current that can go through an LED to make it work is about 0.02 amps. And so since this is a 9-volt battery, it has a lot more than just 9 volts. So we need to use the resistors, these things again, in order to take the current down, bring it down, in order to be used to light the LED. So since I know that the the amps has to be 0.02, and I know that the battery is a 9-volt, I can use Ohm's law, which says that V is equal to IR, or voltage is equal to current and resistance. So I'm using a different variant of that. Since I know my V and my I need to find my R. So I'm just going to use the formula resistance equals volts over current. And so that'd be 9, since 9 volts, over 0.02 amps, which comes out to 450. But and then the LED also has built-in 80 ohms of resistance, so I can go anywhere between about 370 and 450. So I'm going to pull up my cheat sheet on my computer, and basically all it is it's telling me the different color bands on here. Actually, this one might be a little bit easier to see. Now this has a bunch of colors on it. So those colors all tell me something different. Since I need 370-ish ohms, I need to find something that has definitely a brown multiplier, which is the third color of the 4 that are on here. So I found 2 already that meet the qualifications that I need. Since I need 370, I have one here which is red, orange, brown, which with my cheat sheet would be 230, and this one is brown, gray, brown, so it'd be 180. Alright, so then those two together is simple math. 180 plus, what is this one again? 230. Yep, plus 230. So, so that equals 410 ohms, which is just in the middle of what I need, which is perfect. So I have my cables that I need to test, the tip sleeve. So I'm gonna set this up now. Alright, so 9-volt battery. I'm gonna put the this on. Actually, use this one. I'm just going to put this on here. Actually, I want the positive side. I'll put this on the positive side. And then I'm going to put this onto the sleeve. I'm going to come over here, get another big one, put that on there, and then put this on the tip of this one. So there's all the alligators on those, and then this one's going to go, oh, oops, sorry, I put the wrong one on. Okay, so this is going to go back into the tip. So it's going, oops. Alright, so it's going to go through the cable, and it's going to go back through the cable the other way. And then it's going to go, oops, into my resistors. I'm just going to put this on. Would go on. Let's pop. These things are hard to put on. Let's see if I have another big one. Nope. No, just try. So this is just going to go on if I can keep it on. Come on, all these gotta work. There we go. And then this is going to go into the first one of my resistors. This is the 231 ohms. I'm going to link this to my other one, which is 180. And I get another alligator pin, and then connect it to the LED, the big side. I do believe that's the one I want. And then put this over here. And then connect it back to my battery. Oh, that was not good. Alright, let's see if it works. Oh, oops. Yep. I don't know if you can tell, but it's on. Oops. This is not going well. See, there it goes on and off. On, off. So everything works as it's supposed to, which is good, which means I did it right. Alright. That's the project. I think I demonstrated everything. The current went through the positive side of this. So here, bring it back down. So it's going from the positive side right here, and it's going through here into the sleeve. Then from the sleeve, it's going around and around and around and around, around, back through here. It's exiting the sleeve over here and going right back into the tip of this, and then it's coming back, back, back to the tip of this. Then it's going over to the first resistor over here. Then it's going over through that into the second resistor, which adds up to 410 ohms, plus the 80 that are on this. So it's a little dimmer than optimal, but it's still pretty good. And then it goes right back into the ground or the negative side. And that's the current. Alright, that's all.